Hello, my name is Will Drury, and the title of my project is The Examination of Heavy Metals Leaching from Fly Ash Concrete. Fly ash is the powdery byproduct of burning coal. So this means that whenever coal is burned, this powdery substance is created called fly ash. Now, the problem with fly ash is it contains dangerous heavy metals such as chromium, arsenic, and zinc, and fly ash is indisposable. So that means that it can't be burned, it can't be put into the ground. So what happens is this fly ash builds up into gigantic piles that look like mountains. And this is very bad because people live near that area. So this fly ash can easily be inhaled by them and they can be taking in dangerous heavy metals. So here is a fly ash mound. Now, this is a lot larger than it looks in this picture, so it's almost as big as if you can sled on it, and I wouldn't recommend that. So, the heavy metals inside of fly ash are bioaccumulators. That means that when inhaled, these heavy metals will stay in your body and grow over time. Now this is a problem because if you keep on inhaling more of this substance, then it will just grow and grow and grow, and eventually you can get sick from this. Now, a smart scientist found out that fly ash can be used as a substitute for cement. Now this is a win-win because if fly ash is put into concrete, then it's basically being disposed of. And also, concrete is becoming less expensive because this fly ash, which does not cost any money at all, can be put inside of it. So, what I instantly thought whenever I heard this was, can this fly ash come out? Can we be exposed to dangerous heavy metals anytime we walk down the street or down the sidewalk? So the purpose of my project was to find out if fly ash is leaching out of concrete and under certain circumstances or conditions. So I had three hypotheses. One, fly ash will leach out of concrete. Two, the amount of leaching will be the greatest during the frozen sample. And three, the amount of fly ash that will come out of the concrete will be dose dependent, meaning the greater amount of fly ash, the greater amount of leaching. So here are some formulas for the concrete mixture that I created. So, as you can see, there are 22.9 grams of fly ash and 30 grams of cement. Here, there is less fly ash and more cement for the 30% sample. And for the 0% sample, which is my control, there is 0 fly ash and a lot more cement. So, how I went about doing this was I created the concrete using the formulas listed. Then what I did was I collected glass containers and put the fly ash inside of each one. And then I filled them with a certain type of water. Now this water would be either distilled, which was my control water, then salt water, acid rain, river water collected from the Ohio River, and frozen and thawed with distilled water. And after that, I would test the water sample for heavy metals using SynSafe heavy metal testing strips every month. And after that, I analyzed the data. So here is an example of what one of my pieces of concrete would look like. This is a 50%. So here's what I found. For the 0% sample, there was only one finding of heavy metals inside of it. And this is 10 parts per billion in the acid rain sample. Now, this is absolutely minuscule. This is 10 parts per billion. So you can't really say that there are heavy metals inside. So then when we looked at the 30%, you see that all of the samples, distilled, acid rain, all of those, are within 0 and 100 parts per billion, while the frozen and thawed reaches all the way up to 500 parts per billion. So that means that the frozen and thawed is gigantic compared to the others. And then the 50% is basically the same, except the range is larger for the other samples. We're now at 0 to 200 parts per billion. So here are individual water samples. For the distilled, again, this is a tiny spectrum, so there aren't that much heavy metals leaching out of the concrete for the distilled. Then for the acid rain, it reaches all the way up to 250 parts per billion, which is a lot larger than the highest for distilled, which was 75. Now, here are the river water and saltwater sample. So the 50% is much larger than the 30% and the 0%, which is 0. And then for the saltwater sample, this looks very odd because the 0% or the 30% goes from 0 to 15 to 0 to 20. Now, you'd think that it can't go back down, but again, this is in parts per billion, so this is tiny. So you can't really say that there are heavy metals like specifically inside of this water in that small of a spectrum. And here's the freeze and thaw. Now, what you see here is the 50% here and the 30% here. Now, they are so close together because the freeze and thaw does that much damage to the concrete. It has that great of an effect to where the amount of fly ash doesn't really matter. So, in conclusion, after analyzing the data, I have data that would suggest that heavy metals are leaching out of concrete. Hypothesis 2 was supported by the data because the freeze and thaw sample had the greatest amount of leaching by far out of all of them. And then for hypothesis 3, the 50% fly ash sample had the greatest amount of leaching throughout every single sample. So that supports the dose dependency. So the greater amount of fly ash, the greater amount of leaching. So about the freeze and thaw sample, why it has such a great impact is because this water can get into the concrete crevices, the tiny amounts, and every time it is frozen, it contracts, and then whenever you thaw it, it expands. And whenever this is done over and over, it's breaking apart the concrete. So if you look at the 50% after the 8 months that I did this test, you'll see that it's completely broken apart, where all of the other samples, it's not broken apart at all. Completely intact from day one. So what I would like to do in the future is I would like to be in a lab and specifically test for a specific metal. And I would also like to see how much, like the exact amount of heavy metals that are inside of the water samples. Because here we have a rough estimate, like I was saying, the 15 is not specific enough. I want to see it like to 3 decimal places. What I would also like to do, and this is probably unlikely, but I would like to create something that can contain this fly ash inside of concrete, because this is a real big problem, because fly ash is now used in all concrete made in the United States. So if this fly ash is coming out of the concrete, we could be exposed to these dangerous heavy metals for basically every single day. So that's a gigantic problem. And to end off on a sad note, we are basically taking up these heavy metals all of the time. And this is just one more reason why we should push for this clean energy source, because this example of the fly ash and the heavy metals, this is just one horrible problem that's stacked on top of a ton of others that have to do with the coal and oil industries. So, thank you, and that is my project.